Hey folks, how we doing? Mr. Carter here, ready to teach you math lesson 313, comparing decimals. So I'm just gonna go for it and get ready to go. Here we go. Our learning target is, I'm just gonna pull up. Sorry, there you go. Our learning target is I understand how to compare decimals using less than, greater than, and equal to. Here's our math message. It's asking you to write a number sentence using, again, the less than, greater than, or equal to symbols to show which decimal is larger, 95 hundredths or 3/10. So again, here's our math message. So we're comparing 95 hundredths and 3/10. So first of all, I know that 95 hundredths as a fraction looks like this, 95 over 100. 3/10, however, looks like this, 3 over 10. So we learned before that a way to compare fractions together is to have a common denominator. So that's what I'm going to do here. I'm going to take 3/10 and I'm going to make it into hundredths. So to do that, I have to go 10 times 10, tens times 10. That's going to get me 100 here in the denominator. So again, whatever you do on the bottom, you have to do to the top. So I'm going to go 3 times 10 on the top. That gives me 30 hundredths. So now we can compare the two fractions. So we can compare 95 hundredths with 30 hundredths. And we know that 95 out of 100 is greater than 30 out of 100, right? So if you have that pizza and you have 95 slices of it, you're definitely having more pizza than you would be if you would have 30 slices out of 100. So therefore, 95 hundredths as a decimal is greater than 3/10 as a decimal, which is what our original question is. Here's another way to look at the same problem, comparing 95 hundredths and 3/10 using some visuals. So if I had 95 hundredths, it would look like this, right? It would be 95 small cubes out of 100, or 9 longs and 5 cubes, right? 9/10 and 5 hundredths. So here we have 3/10, which is 3 longs, or 30 out of 100. If you counted all these little cubes, there would be 30 of them out of 100. So again, as you can see by the visual, there's a lot more cubes here on 95 hundredths than there are here in 3/10. Another way to look at it using a visual is a number line. So here I have a number line from 0 to 1, and there's 100 little lines here. So I split this number line into 100 little lines. 3/10 is right here at that 30 mark. 30 like little lines here. That would make 30 if you would count them. Or you can go 3/10. Every big line here is a tenth, so that would be 1/10, 2/10, 3/10. And then way over here is your 95 hundredths. Obviously, that's larger. It's closer to the whole here on the number line. Okay, so here's another math problem. Yes, another math problem. Nice. So we have Caitlin, and she agreed with the math problem we just did, that 95 hundredths is greater than 3/10. So she agreed with that. And she said this is true because 95 is bigger than 3. So do you agree with her reasoning? Will her strategy, let me just move this over here. Will her strategy work when repeated with any other pair of decimals? So what I'd like you to do right now, pause the video, think about this problem for a minute before you answer it. Maybe talk with somebody that's close by, whatever you want to do. But again, she's saying that 95 hundredths is greater than 3/10. That's because 95 is greater than 3. Do you agree with that? So pause the video and think about that for a minute. Okay, welcome back. If I can go on to the next slide. There we go, sorry about that. Caitlin, so here's the problem again. Do you agree with her reasoning that 95 hundredths is greater than 3/10 because 95 is greater than 3? Well, no, because no. She is not correct. And I'm going to show you an example that disproves Caitlin's reasoning. So, if you were to compare 23 hundredths with 9 tenths, if you went by Caitlin's example, then you would say that, well, 23 is greater than 9. So obviously, 23 hundredths is greater than 9 tenths. Well, that is not correct, and here's why. 23 hundredths looks like this as a fraction, right? 23 over 100. Well, 9 tenths looks like this as a fraction, which, as we know, when we convert it, is the same as saying 90 hundredths. Well, here you go. So 23 hundredths is not bigger than 90 hundredths. So it has to be less than. So you can't just go by the numbers. You can't just say, okay, 23 and 9, 23 hundredths is definitely larger than 9 tenths. It doesn't work. You have to think of the decimals. You have to think of the visuals, right? Okay, here's another problem. So here's a can of soup. It weighs about 3/10 of a kilogram. We have a centimeter cube that is 95 hundredths of a gram. Which one weighs more? Well, last time, that math message problem, we said that 95 hundredths is greater than 3/10. Remember, here's the visual, 95 hundredths and 3/10, right? 95 hundredths is larger than 3/10. So that means the centimeter block is heavier than the can of soup, right? Because the centimeter block is 95 hundredths of a gram, and the can of soup's only 3/10 of a kilogram, right? No, because because the holes are different. Here, my friends, the soup can is weighed in a kilogram, and our centimeter cube is weighed in grams. So the comparisons are only valid when the holes are the same. So you have to pay attention to what your hole is. Okay, so you can't just, again, compare the fractions. You got to think about what the whole is, because it's like comparing apples and oranges. They're not the same unit of measurement. Okay, here's another math problem. Yes. In the 2012 Summer Olympics, American swimmer Missy Franklin won the 100-meter backstroke. The times of the top two swimmers were 58 hundredths and 68ths. I'm sorry, 58 and 68 hundredths of a second, and 58 and 33 hundredths of a second. Which was the winning time? So here's the problem again. So we are comparing these two times, 58 and 68 hundredths, and 58 and 33 hundredths. Well, 58 seconds is whole seconds for both times. So we're going to look at our holes first to see. Well, since our holes are the same, now we look at the values of the decimals. So we don't need to focus on the holes because we know that there's 58 whole seconds for both times. So our first decimal we're going to look at is 68 hundredths. So again, that's 68 over 100. Visually, it looks like this. So it's 6 longs, 8 cubes for 68 hundredths, or 68 total cubes out of 100. Over here, we have 33 out of 100, which again visually looks like this. 3 longs and 3 cubes, right? 33 hundredths. So now we can compare these two fractions. But wait a minute. Which was the winning time? Well, we know that 58 and 16 hundredths is larger than 58 and 33 hundredths. But the winning time is not actually the largest number. The winner has the smaller time, or the shortest time. I should have said shorter time. Because obviously you want a faster time because that means you cross the finish line first, right? So you want to look at whose time was the least. So the winning time was the smaller number here, which was 58 and 33 hundredths of a second, because that means that swimmer was just slightly faster than that swimmer there. So again, you want to pay attention to these problems and think about what it's asking you, okay? So here we go. Now you have to work on page 102 in your math journal. Looks like this. You're going to have some comparing of decimals, and they're going to ask you to shade some in. Use the greater than, equal to, or less than sign here, and put numbers on a number line and all that good stuff. So there you go. Hope this was helpful. If you are stuck, please check in with your teacher. They'll be able to help you. Take care.